Well, hello, it's Cliff here from Down Under. In this video I'm going to go through single point threading on a center lathe, how you can quite easily cut a very accurate thread on a center lathe using the set over top slide method and the 3-wire method for measuring the thread. I'll go through the different stages in this video. I'm going to cut this gauge external thread and this gauge internal thread that fits on it. And this is in preparation for a small production run of spindles that I'm going to make for Thread Express. And they're going to be machined between centers in my center lathe. So it's not an ideal application for Thread Express. Thread Express is an attachment that allows you to cut threads and index very quickly and rapidly. For short to medium length threads, it saves a lot of time overdoing it in a center lathe, but there are still some jobs that better suit a center lathe. You often need to cut a precision thread to specifications and you don't have the part that the screw thread fits into. That may be at a remote location, or you may not have a nut or a screw conveniently. But you may be shipping a part out to somebody in a different part of the world, and you have to be sure that it fits. And so you need to be able to use agreed on specifications. And the effective pitch diameter is the key specification that you need to be able to measure to be sure that your thread is correct. Not just the depth of thread, but the effective pitch diameter. And so I'm going to go through using the 3-wire method to measure and check your thread, but I'm also going to be using cheap Chinese full form thread inserts that only cost a few dollars and testing those out and going through the method of how you can cut a precision thread. Make sure you always clean your lead screw before screw cutting. You really don't want chips and swarf left in there. The bronze half nuts clamp down on either side of the screw, and you can imagine if there's bits of chips or swarf in there, they could embed into the bronze half nuts and you'd get very poor engagement and you'd get hard steel chips carving and scoring away on the lead screw. You really don't want that to happen. And even with these covers, which I've pulled back at the moment, clamp them back on the bed stock there, with those telescopic covers, they're really good. They keep out 99% of the chips, but even so 1% gets through, and that 1% can do damage to your lead screw very easily. So don't shortcut on that. Always keep your lead screws clean before you do screw cutting. So I'm going to machine a master thread or a thread gauge or gauge thread to the specifications for a 32mm 3.5mm pitch thread. So I've got a full form threading insert set up there. I'm setting the tool at right angles to the center line of the spindle and set the top slide round at 30 degrees, half the 60-degree angle, and getting set up now to do some precision single point screw cutting. If you want to cut an accurate thread, it's worth spending a little bit of time studying the specifications. There's quite a lot to it. Ultimately, you want to measure the effective pitch diameter with 3 wires to really check that you've got the correct thread size. But initially, if you've got full form threading inserts, you can touch up on the major diameter, the external diameter of the male thread, and set the tool to just scrape on that surface and then set up your cross slide or your top slide to index in the correct amount, which is the difference between the major diameter and the core diameter. That's that radius diameter there. If the full threading insert has been made exactly correct. But as we get close to the final size, we'll be checking it to get the effective pitch diameter, the correct effective pitch diameter. So because I'll be indexing or setting the cut in each time using the set over top slide method, I'll be increasing the depth each time with the top slide dial, and I'll set it up with a little felt pen mark at the theoretical full depth. That way I can just back off each time with the main cross slide hand wheel, come into 0 on the digital readout and put the cut on each time. This way is really simple, and in order to work out where that felt pen mark goes, where the destination core diameter is, again I can use the digital readout to come in to a setting 0, for example, then back off the depth that I want to go, and then wind in with the top slide until I hit the same 0 on the dial, and then I can make a mark, a felt pen mark on the dial, and then that set it all up. So I'm not doing any brain work during the actual screw cutting. I've already got a little mark I can head towards. So just to reiterate that in case it was confusing to you, because we're indexing the tool in on the angle, we need to have a mark on the dial at the final depth, and in order to work out where that is, we could calculate it with trigonometry, or we could use our CAD software, or we could do a drawing, a 10 times drawing, but we can also use digital readout by using the dial indicator, backing off at right angles and then going in at the angle of the flank of the thread, and that automatically finds it for us on the machine. Is that starting to make sense? So the thread depth from the outside diameter of the thread to the core diameter is 2.145 millimeters, or in diameter mode 4.29. So we set our digital readout on 0, our dial indicator on 0, we back out 4.29, and we come in now with the cross slide set at the 30 degrees on 0 until we hit the dial indicator line. Coming around there now to 0, and we make a mark, and it's just 1 digit short of 0 on the hypotenuse of the triangle down that sloping flank. And then take a shave cut, put some marking ink on the part and take a shave cut and check that you have got the correct pitch with your thread pitch gauge. And you can see there that I got it wrong the first time, so it's really worth doing that. And you know why I got it wrong? This blasted lathe, it's got an error here in the gear change position. If you set it on position 8, it's actually on position 6. You've actually got to go down below position 8, and I just found out there it was engaging in the wrong gear. So good thing I didn't go ahead and just trust all the settings. Always check them before you start removing serious metal. So it's a good idea to run the lathe quite slow to start with and take quite light cuts until you get coordinated. So you're backing off each time with the cross slide and then coming back into 0, and all you're doing is advancing the cut each time with the top slide. Say a conservative amount to start with, say 1/4 thou or 0.1. Disengage, back off, say 1 revolution, index to the end of the part, I'm back in that 1 revolution to 0 on the digital readout. Put in your cut. Get ready for the number to come round on your thread dial telling you the correct position to engage, which is there. And we'll probably speed it up once we get our confidence up. Back off with the cross slide, 1 turn, back in to 0, put our cut on. Easy as that. Of course, if you're going to speed it up, don't speed it up by changing the gears in the headstock, because that could reposition your thread in the wrong place. I mean speed it up by going from single speed to 2 speed on your electric motor. Well, here's the threading indicator dial. I don't know how much I should be going into the basics in this video. You look in there on your little chart or in your manual to see just on what number you should engage. When that number comes round next to the little button or line, that's when you engage. Otherwise it may not match up with the thread you're cutting. So now I've roughed it down almost to size. That's about 24 cuts at 0.1 of a millimeter, or 4 thou. Of course the depth of cut will vary depending on the metal you're machining and the tool you're using and all those sort of things, but this is just for this job. Now I'm going to finally dial in the exact depth. And how do we get the exact depth? Well, there's 3 ways I'm going to use, and all 3 methods should all line up ideally. I'm using a full form threading insert, so it should take a shaving off the top of the thread when it gets to full depth. That's one method. Another method is I'm using the depth of the dial. That's the hypotenuse of the triangle. And the third method, the most accurate, is I'm going to measure the effective pitch diameter with the 3-wire method. So we've stopped short about 0.1, 3 or 4 thou on the radius at that angle. So we're going to set up the 3-wire method now. It's a good idea to get a bit of polystyrene or foam that holds the wire for you approximately in place, because it's quite difficult to measure. And I'll just take you through measuring that diameter with the 3 wires and looking it up in the little chart, show you how that all works. So this is just our first measurement. I'm just doing this to demonstrate it quickly. So come in here across the 3 wires, find the maximum diameter, and make sure that your bit of foam is not biasing the little pins. And we are about 33.2. That's an initial measurement. Okay, let's talk about using the 3 wires just briefly. So in with the wires comes this little information chart, and what we want to know is what is the diameter across the wires that we need to achieve for the thread we're cutting. You can see the micrometer anvils there dotted, and the dimension is dimension M. And if we look on here, the little formula, M equals E plus constant, and E is the pitch diameter, the effective pitch diameter. Well, we know from our specifications that the effective pitch diameter is 29.727. We add the constant. Okay, let's look inside the chart now. So for a 3.5 pitch, we have a wire size and a constant, and we get the information from there, which is adding the constant of 3.141 to the pitch diameter, which is 29.727, and we get a theoretical measurement of 32.87, and what we just measured was 33.2, so we have about 0.3 on the diameter, about 12 thou, or about 6 thou on the radius. That's around about where we were at with our dial, so that's encouraging, and now we can go ahead and get a bit closer to that. So up to this point we've been cutting down the side of the flank at that 30-degree angle, but now we want to actually go straight in with the tool with very small cuts, so that we are shaving off both sides of the thread and cutting it to the exact form of the full form threading insert. So we're going to abandon this position here, which is just short of our mark, and just go in now with the digital readout in that last few thou. So I've slowed it back down now. I'm going to put cutting oil rather than coolant, because we want to get a nice finish. And I've put a cut on straight in with the tool. We wait for our little number to come round on the dial. What I'm going to do now is a little bit different. I'm going to engage. And when I get near the end, I'm going to switch the actual lathe off. Here I'm going to disengage the power now and put the brake on. Now I'm not disengaging the half nuts anymore now. I'm going to reverse out. Put on a bit more coolant, a bit more cutting oil, sorry. Now this is a little bit slower, but it avoids the inaccuracies of engaging and disengaging the half nut, and so it's staying engaged, and we're cutting on the full form. So we remember that dimension that we had on the X. We'll go back into it and we'll put on another cut. Looking at our form, here we go again. Switch the power off just as we come to the end, put the brake on, back out and reverse. We're still not quite shaving on the crest of the thread, which is good because we still have a couple of thou to go. So by that process, I won't go through it all step by step. I'll go off camera now and concentrate, but you can see by that process we can dial in the last few thou just shy of the theoretical depth, and then do another 3-wire measurement. Cutting this way by leaving the half nuts engaged and reversing out is actually easier. It's just that it's slower. So we had about 0.3 to take off the diameter, 0.15 or 6 thou on the radius. I've gone in 0.2 now off the diameter. Put on the brake, back off. We're still not quite topping the threads with the insert, which is good. It looks like the cheap Chinese full thread cutter insert is pretty accurate. We'll know soon, but we're getting within a couple of thou now. So finally, a couple more cuts. So we've gone in 0.2 on the diameter. We'll go in 0.25 now. 0.25. Still not quite taking off the crest of the thread, but the thread's looking pretty good. Back out, reverse out. So we're going 0.3 on the diameter now. That is almost the amount that we calculated needs to come off. Still not quite cresting the thread. Finally, we'll go in the specified or the calculated amount, 0.34. I'll be amazed if it's that accurate. No, let's play it safe. Let's actually get the 3 wires out and check them again by measurement. Okay, so let's put our 3 wires in now. Remember, we're aiming for 32.87. It's a bit of a fiddle. That's why I think it's important to have a bit of foam fumbling this. Trying to keep out the way of the camera and get the wires in the right place. I should really be just concentrating on showing you the procedure rather than making an accurate measurement. I'm trying to do too much at once. But so what you're trying to do is get the mic anvils to cover all 3 wires at the maximum diameter. And I'm getting, and not let the foam interfere with it, I'm getting 32.9. So we've 9.1 maybe. So we're about 4/100ths up. That's less than 2 thou. That's about 1 thou off the radius. So we're almost exactly on size now. So just a couple of spring passes is really all that's required. Now, do you use cutting oil for spring passes? Some people would say no, that prevents the cut. Other people say always use cutting oil. I'm not sure. I might use a little bit. Turn the power off about there. Put the brake on. Looking good. Okay, so I've taken a couple of spring passes and I'm on the theoretical depth now by engagement of the cross slide. Let's have a measurement across the 3 wires. So we're using 3 methods to confirm the final thread depth. The depth of top slide and cross slide engagement measurement with the 3 wires, and the form of this little Chinese cutter, which is amazingly good for the cost of it. I mean, you know, a high-end industrial brand with the tools, I was looking at paying about 1,000 New Zealand dollars. That's about 600 or 700 US dollars for the internal and external inserts and the shanks, because I had to go up a size and I would have to buy new shanks. So about 600 or 700 US dollars versus buying a pack of 10 inserts that fit in my existing tooling for only about $15 US. What's this world coming to? Here's the little inserts I bought. Descar ER 16ER 3.5 ISO. So, you know, $16, $16.96 plus shipping and GST. $25 New Zealand. That's, you know, $15 US for 10. Crazy. There must be a lot of Chinese government subsidies going on to help with the cost of manufacture. But they're amazingly good for the price. So remember, going off our little chart, we're going for a goal across the wire's height of 32.87. And let's see if I can do a measurement now. 32.8586. That's just bang on. Well, the finish is a little bit teary, not too bad. I can blame the Chinese insert. If I bought the expensive industrial brand, I couldn't blame the insert. It's quite convenient, isn't it? Anyway, that's quite a nice thread, and it's come to spec. Very happy with that. It's just starting to top. By that I mean the full form is just starting to shave on the outside diameter, and the outside diameter is a theoretical measurement of 32, but you want to be just very slightly under that, and we are 0.02 of a millimeter under that. Depending on the class of thread, you know, a high class thread would be just a shade under like that. A low class thread might have 0.1, 0.2, you know, 4 or 8 thou clearance on the outside diameter. Trying to give you a close-up of the thread that we've just cut. It's pretty good overall. I wonder if there's not quite enough clearance on that cutter. It's sort of given a very glossy finish, like it's rubbing, and then it's a little bit teary in one or two places. So, you know, it's not perfect, but good enough for what I want anyway. Thanks for watching that video through to the end. I've got quite a few tips and tricks left over, but really the video is getting too long-winded. So the next video is going to be about cutting an internal thread to fit the external thread, and there'll be quite a few tips and tricks stacked into that video as well, to do with general precision threading. Please keep an eye out for the next video, part 2, and I'll see you there. Cheers. I hope you found something useful there. If you did, please like, and if you're not already subscribed, please subscribe so you can stay tuned with notifications for future videos. Catch you next time. Cheers.